Alright, so this is the first video in the video series for trigonometric functions. So we're going to be looking at additional trig terms, we're going to be looking at additional trig identities, graphs, how to solve equations, proving and simplifying. So it's going to be quite a long video series, so we're going to go through everything that is needed for chapter 6 and 7 in the Year 2 Pure Edexcel book. So if you're following along, we're just going to go through those curriculum points. Alright, so first things first, we learned in book 1 about the sine, cos, tan trig functions, right? But there's actually 3 more functions that we need to be introduced to, and those are the sec, cosec, and cot functions that I've written out for you here. Now they're actually related to the sine, cos, and tan functions. So you can see that sec is 1 over cos, cosec is 1 over sine, and cot is 1 over tan. So you just have to memorize it as that. It might take a bit of time, but just as you get used to it, you will start to memorize it. Right, so with this, what we can actually do now is we can actually solve additional questions and additional problems. But first things first, in our cosec calculator, we have the sine, cos, tan functions, right? So we can work out what sine 50 is, or like sine 30, or tan 40. However, you will notice that you don't actually have the cosec, cot, and cotangent functions. So if the question asks you to find something like cosec 30 degrees, then the way we actually find that is we'll rewrite it as 1 over sine 30, because we know how to work out or find sine 30 using the calculator. So that's just going to be 1 over 2, so it's 1 over 1 over 2, so cosec 30 is just 2. So that's how you'd work out exact values of some trig functions that we just looked at here. Right, moving on, they all have their own graphs as well, which we also need to be very familiar with and be able to use very well. So we need to be able to draw them as well. So I'm going to tell you how I go about memorizing or just drawing them. So first things first, if we were to try and sketch y is sec x. So the way I go about memorizing it is, well, I know that sec is 1 over cos. I'm going to sketch a cos graph, okay? So cos looks something like this. And then from here, all these 3 functions, they all have asymptotes, okay? So for this particular one, the asymptotes are when this cos graph crosses the x-axis. So now I'm going to draw my asymptotes first. So just sketching these asymptotes. Right, after I sketch these asymptotes, now within each asymptote, I just flip it up and down. So what I'm talking about is within here, I just flip this part up, I flip this part down, up, down, up, down, up, and down. So that's how I go about actually memorizing or learning to sketch the y sec graph. So if I was to just sketch it on its own, then it would look something like this, here, 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 like here, with asymptotes at certain positions like so. Okay, so this is the graph for y is sec x. Right. Once we've drawn it, we also need to know the domain and ranges, okay? So remember the domain is the possible x values, range is the possible y values. So you can see that actually the domain x is going to be all real values except for when it's at the asymptotes. So x can't be at these asymptotes, and the way we work it out is when the cos graph crosses the x-axis. So this will be when x is 90, this will be 270, minus 90, minus 270. So you can just see we're just adding 180 each time, right? So it's going to be 450 and so on. So the asymptotes are going to be 90n, where n is an odd number. So any multiples of 90, right? But for only n being odd numbers. These are going to be or the values which x can't take. Right, the y values. So you can see here is we flipped it up and down, right? So these points are still going to be 1 and negative 1. So y can also be all real numbers, and y has to be larger than or equal to 1, and y has to be less than or equal to minus 1. So it can't be there's no values between 1 and minus 1. And that's the sec graph. For the cosec graph, I do the same thing. But this time, rather than sketching this sine graph, I sketch rather than sketching the cos graph, I sketch the sine graph, because cosec is 1 over sine, right? So first of all, just quickly sketching the sine graph. And then we know the asymptotes lie when it crosses the x axis. So I draw the asymptotes here. This is also the asymptote when x is 0. And this. And then these still points are still 1 and -1. And from here, I flip it up and down like I did before. So within each asymptote, I flip it up and down. And this now is going to be my cosec graph. So if I was to draw it out on its own, it would look something like this, where here is 1 and -1, and then these will be its asymptotes, where it's when it crosses it. So this would be theta is 180, this is when it's 360, 0, -180, and -360 as well. So that's the sec graph, so the cosec graph. Right, domain and range, so x once again can be all real numbers except when it's at the asymptotes, and these asymptotes are when it's not equal to 0, and x can't be equal to multiples of 180. So I'm going to write it as 180n, where n is any integer. It doesn't have to be odd or even, it could be any integer. Y once again can also be real numbers, and y has to be bigger than -1, y has to be less than -1. It can't lie in between there. There's no solution, but it does lie in between them. So that's the sec graph, and so the cosec graph. Lastly now, we need to sketch the cot graph. For cot, it's 1 over tan, but the way I like to do it is I like to sketch my asymptotes first. So these asymptotes are always going to be multiples of 180. So it's x is 180, x is 360, x is -180, and x is -360. And then the tan, I look at the tan shape, right? The tan shape looks something like this. But for the cot one, the shape is flipped, meaning that it's actually going to look something like here. So imagine just flipping the shape around. And this is going to be my cot graph. Domain and range, well, once again, x can be all real numbers except at these asymptotes, so it can't be 0, and it can't be any multiples of 180 again. So it's the same thing as y is cosec x. The range, well, y can actually be any real numbers. There's no numbers which it can't be. Okay? So these are the 3 graphs of the new functions that we've learned, the trig functions that we've learned. Make sure you're very, very familiar with them, with all the asymptotes and the ranges and stuff, because you're going to be asked to transform these graphs and just look at different solutions related to these graphs. As I said, you have to be very familiar with them because then they will ask you to transform them. So we've learned about graph transformations in previous chapters, right? There's 6 of them. And so we can apply them, the same methods, to these 3 graphs that we just learned. So it's the same exact method that we used for when we were looking at transformations earlier. So let's just try a couple of these. So let's look at y is sec 2 theta. We know that 2 theta, or the 2 is inside the brackets, so it's going to affect our x values and do the opposite of what you would expect. So it's going to, rather than multiply, we're going to divide every x value by 2. So I first draw out my sec graph. Sec is 1 over cos, so I like to draw my asymptotes first. So these will be when theta is 90. This is 270. We only need to draw up to 360 degrees, so we can just draw these. And now, because it's divided by 2, this is actually going to be the asymptotes are now going to be divided by 2 as well. So 45 and 135. I'm not going to draw the rest because this is repeated. And we just flip it up and down. So this will flip like this, here, here, and so on and so on and so on. 1 and -1 like this. Let's just try another one. So let's try maybe the second one here. So D, y is cosec theta minus 30. So once again, there's only one transformation that occurs there. It's the minus 30. It's inside the bracket, meaning it's going to affect our x values, and do the opposite. So rather than minus 30, we're going to add 30 to every x value. So once again, I sketch out the asymptotes first, so I know where it's going to lie, right? So for cosec is 1 over sine, meaning that the asymptotes are when theta is 0, and every multiples of 180. Like this. We know it's going to plus 30 to each one, so the asymptotes themselves are going to move to the right by 30 as well. So I'm going to draw out again. But the new asymptotes are when theta is 30, theta is 210, and theta is 390. And then I just sketch out the cosec, which is 1 over sine. So that it's going to lie here, here, and there's going to be a certain one here as well. Where here is 1, and this is -1. Okay, so as you can see, the transformations themselves, the method we use to apply these transformations are exactly the same as the ones we've learned previously. So if you're still unfamiliar or you just forgot about these transformations, maybe you can go back to the videos or the transformation videos that we were looking at earlier in the series. So this is just an introduction to the 3 extra trig functions that we can use from now on. In the next videos, we're going to be looking at simplifying it, and we're going to look at creating more additional identities as well from these functions that we've just learned.